So we've already learned how to find the percent composition of a sample, but often what I want is to know how much of a particular substance I can get from a sample. The equation is the same, we're just solving for a different piece of it. So here I have a 452 gram sample, and I know that it's 32% iron. I want to know what mass of iron I can obtain from this sample. So the equation, the percent is equal to the mass of the part divided by the mass of the whole times 100. Before, we knew the part, we knew the whole, and we found the percent. But here, we're given the percent. So I have 32% is, I want to know what part of this is iron, divided by my entire sample is 452 grams. So I have the percent, I have the whole. I'm simply going to solve for x. And when I do that, I get x is equal to 140 grams. Notice I do have two significant figures. The 32 has 2, the 452 has 3, and this 100 has an infinite number of significant figures because percent does mean out of 100 exactly. So this is one of the easier examples where I know what the percent is. However, sometimes I might not know what percent it is. So I know that I have Cu2O, and I want to know how much copper I can get from a 42.3 gram sample of this compound. So here I have the whole, I'm looking for the part, but I don't have the percent either. But if you remember, we found the percent composition from the chemical formula. So again, we have percent is part over whole times 100. So the first thing I need to do is find what percent of this compound is copper. So percent equals, now I'm going to look up the molar masses. I have 2 coppers. Each copper is 63.546 grams. And when I add up the 2 coppers and the oxygen, I get 143.0914. which gives me about 88.8%. Now this is not my final answer, so you're going to leave the entire answer in your calculator until you're done, but this is just a stopping point for now to make sure that you have the correct answer there. This is the percent that is copper. I can now use the percent composition formula again. Percent equals part over whole times 100. Well, now I know that the percent is 88.8. Again, leave the entire answer in your calculator. And this sample that I have has a mass of 42.3 grams. I want to know what part of that is copper. When I solve that for x, I end up with 37.6 grams. So we can find what mass of copper I can get from a sample only knowing its chemical formula by using the percent composition formula twice. Once with the chemical formula to get what percent of it is the element that I'm looking for, and then taking that answer, plugging it into the percent composition formula with the sample size to find the part that is that sample. So we can do it in 2 steps, or we can kind of combine it into 1 step. So we can do percent is equal to part over whole times 100. which is equal to part over whole times 100. The percent composition is the same regardless of what my sample size is, whether it's the 1 mole or the 42.3. So I can kind of get rid of the fact that it's a percent. I have part over whole with the formula, and then part over whole with my sample. And I can divide both sides by 100 to get rid of that times 100 piece. The part over whole with the molar masses from the chemical formula equals the part over whole of the sample. So here I would say the part with the formula would be 2 coppers over the entire formula, 143.0914. So part over whole with the formula equals the part that's copper over my entire sample, 42.3 grams. And then I can cross multiply from there and I will get the same answer of 37.6 grams. So you can either use that percent composition formula twice, once with the chemical formula and once with your sample size, or you can essentially use it twice, but setting them equal to each other because the percent that's copper equals the percent that's copper, and set up a ratio of part over whole equals part over whole, one side with the formula and one side with the sample, and get your mass from there.